Okay, so this is the packet exploring exponential functions, and I don't need to read everything to you, but what I think is important for you to underline or highlight is the fact that this is one example of an exponential function. Okay, and we're actually going to be working with this formula in a couple minutes in compound interest. But what I want us to really focus on is this graph. So this represents the population of the world. And what you have to understand is that if you just look at a small piece of this, it looks linear. But over time, you're going to notice that there's like a sweet spot where all of a sudden it just jumps and it starts to climb really fast. Okay. And this is what happens when you spread a rumor, when you spread a virus, when you are sick, and it also happens in the reverse when you are trying to kill a virus by taking medicine, radioactive decay, and temperature cooling. So all of these things are exponential, and it looks like this. See here, slowly at first, then steeply rising. Okay, so this is what we're looking at. This would be considered growth. Now, they have a constant growth factor, and it's that they get multiplied by the same amount. So in order to find your constant multiplier, what you're going to do is you're going to divide your second divided by your first, and that's what's going to give you your growth factor on the y's. So if you take your y value for 6 and divide by 4, and you take your y value for 9 and divide by 6, and you take your y value for 13.5 and divide by 9, you can see if it's exponential. So 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. And 13.5 divided by 9 is 1.5. That means that you have a constant multiplier of 1.5 and that it is exponential. So again, you have to divide the next by the previous, next by the previous, next by the previous. And as long as they're constant, then it's considered an exponential function. This is if you have data. Here, to see if it's exponential, I would do next divided by previous. So I would do 60 divided by 50. Then I would do 70 divided by 60. And then I would do 80 divided by 70. And we're just checking. 60 divided by 50 is going to give us 1.2. 70 divided by 60 is going to give us 1.16 repeating. And 80 divided by 70 is going to give us 1.14. So these are not exponential. They do not have a constant growth factor or a multiplier growth factor. They do go up by the same amount. This one is actually linear because it increases by the same amount every time, by plus 10. Here, we're going to take the next divided by the previous. We would do 48 divided by 96. We would do 24 divided by 48, and we would do 12 divided by 24. So 48 divided by 96 is going to give us 0.5. 24 divided by 48 is 0.5. 12 divided by 24 is 0.5. So this is considered exponential. Okay. Now, what's the difference between this exponential and this exponential? When it's above 1, this is going to be growth because it's more than 100%. Because it's the value for your growth factor is greater than 1. When you have something that's less than 1, this is called decay. And it's decay because it's less than 1, so you're